All right, so with this lesson, we're doing synthetic division still, which in my opinion is the hardest part. I should say we have synthetic division and factoring today. So if you can do those two things, for the most part, I think you're pretty set. But we're going to do synthetic division to find the zeros. I also should have added to because I changed it. We're also synthetic division when you end up with a remainder and what you do with that. So the first thing I want to show you is back in the day, 320 divided by 6. Set that up, and you do not have to do this. Obviously, you're not going to have a question like this on the test. That said, you guys probably better years since actually done long division, so I definitely have to do that. So if you take 6 or 320 by 6, how many times does the 6 go to 3? None. So then you go to the 32. How many times does the 6 go to 32? That's 5. That gives you 30. Then you subtract those. Under 0. How many times does the 6 go? 3, which is 18. That gives you 0. Sorry, that gives you 2. There's no to bring down, and so when you were in elementary school, you did this, and then at the beginning, you would say 53, and then you'd say R2. That's good for remainder. 53 with a remainder of 2. I don't know if you guys remember doing this, because I feel like it was like 2 days when I was in 3rd grade that we did this, and then we never talked about it. To do this more accurately is, instead of having a remainder, you take that remainder and you make it a fraction over, so that's always the numerator, your denominator is then divided by, so we'd have 2 over 6. Obviously, yes, we would reduce that in normal circumstances, but we're not going to talk about that right now. That last thing where we take what the remainder is over the thing that we were dividing by, that's what we're doing today. I apologize, but I'm hoping to make that connection with some of you. But again, that's literally all we're doing today. We're doing synthetic division. And then at the end, whatever we have as a remainder, we're putting up with the, we're putting it as a fraction over what we're dividing by. It's going to look kind of strange, but that's okay. Hang with me. Last thing I will say with this before we start, remember the only time you will ever possibly have a remainder, doesn't mean you'll definitely have one, but the only time it's possible to have a remainder in this chapter is if it's set up with the division symbol like these. If I tell you that x minus 8 is a factor, that by definition means you are not going to get a remainder. That's what a factor means. Or if I this, and then I say x is equal to 8 is 0. Again, by definition, that means that is a factor, so that means that you do not have a remainder. So when you're taking the test, you don't have to worry about a remainder unless you see this division sign. Now again, if you do everything right, that doesn't really help you. That's worthless information. I think it's very helpful. You're going to get zeros, or I think that's a good way to check your work, and I think that's a good guide to know the ones you do get 0 for remainder and the ones that you might not. So these are the ones you might not, if you have it just with the division sign. So remember the way we started this, if x is equal, we have x minus 8, that means x is equal to 8. And so we set up this with our synthetic, it goes in a box, and then we have our coefficients. We have 1, -7, and -1. We usually don't do it quadratic like this because there's not much to it, but that is okay. Now again, but hopefully this kind of rings a bell. The first step, we drop that 1 straight down. The loop was we take 8 times 1. That goes up in the next column, and then we add straight up and down. So -7 plus 8 is 1. Do that loop again. 8, then add those together, you get -3. Time we've had a remainder. So we'll talk about the remainder in a little second. Everything else is the same. So what I mean by that is a constant x. Today, especially putting an R here, just because some people get confused and put the C over there. What we did the other day is look at that. We said, okay, so this is 1x plus 1, and that's usually where we're able to get the other day. Because we didn't have a remainder. That's where we will stop. Now that we have a remainder, remember what I said over here. All you do is you take what your remainder remainder is, I had 2, over whatever you're dividing by. Well, now our remainder is 3, -3, sorry. You put that over the thing we divided by was x minus 8. The only other thing you have to remember that's not included in the other one is you're actually just adding those together. Now, there are times that you are subtracting instead of adding. We're not going to talk about that. We're always going to add. Easier. That's the only difference when you have a remainder. You do the exact same thing we did the other day. The only small difference is when you're done, you just put plus, and then your remainder over that x minus 8. I will say, be careful. A lot of people will either do -3 over +8 or -3 over x plus 8. They've been dealing with +8, so they forget that it's actually minus over here. So just always double check. It's always when you're dividing by it here. Not your 0, it's by that bottom. So, moving on to number 2. It's the same thing for all these. That is x is equal to -2. That goes in my box. Coefficients I have 1, +7, +14, +3. That one straight down. That's how we started. I have to go like too quickly, but I'm hoping you guys are getting pretty good. -2 times 1 is -2. 7 plus -2 is 5. 2 times 5 is -10. Add those together, +4. 2 times 4 is -8. Add those together, -5. Have that. That is our remainder. We have a constant, and then remember we have x squared, x to the third, x to the fourth, x to the fifth, keep going until you run out of numbers. And with 1x squared plus 5x plus 4 plus remainder is -5 over the thing divided by x plus 2. The other thing I had with this lesson was when the number in the box up here, this -2 is a fraction, and I decided it was more important to not do that and more important to do these remainders, which also could possibly be wrong. And this number 3, again, I don't know why the exponent of 2 is a little bit higher than the other ones. That's okay. Probably doesn't bother you guys. Same thing. There's no difference. We have x is equal to +5, so that's what goes in the box. -10, 20, 36. Drop the 1 straight down. 5 times 1 is 5. Add those together. 5 is -25. Again, don't be scared to calculate when you're adding those, because I know adding and subtracting sounds super simple, but when you throw positives and negatives in there and 2 negatives and stuff, it does get a little bit more complicated. I would rather you get those right and use your calculator. 25, add those together is 1. So again, we have my remainder, my constant, x squared, x to the third, x to the fourth. Remember your constant, you could think of it as x to the 0 if that makes that pattern a little bit easier to remember. But we end up getting 1x squared minus 5x minus 5 plus, you always do plus for our purposes. The remainder is 1, so 1 over x minus 5. I really like this lesson because you are learning more about synthetic division. You're learning a little bit, but really the biggest thing with today, in my opinion, is you're getting a lot more practice with synthetic division, because I think that's the hard part, which hopefully isn't that difficult, but that's brand new to you guys. go ahead and do number 4 on your own. I'll give you guys a little bit of time to do that. Then we'll move on to the other parts. All right, my answer is up there. Again, I've said this before, but just a couple quick things that are some very common mistakes. Because again, in my opinion, and I could totally be wrong, my opinion doesn't really matter much at all. But in my opinion, especially synthetic division, it's really not that hard with the math. The math isn't bad. We're multiplying and adding. That's not terrible. The hard part with synthetic division is there's a lot going on. So a couple of common mistakes people make. I just want to highlight this. Double check to make sure you're finding that x is equal to positive 7. Also goes hand in hand with positive 7 in your box. A lot of people see the minus 7, they put a negative 7 there. On the problems that you know you're going to get a remainder of 0, hopefully that's your mistake if you do that. But if you're going to get a remainder, if you use negative 7, you'll get an answer. It'll be a weird answer kind of, but you'll end up getting a remainder and it'll look, I mean, not much more weird than our and then again, make sure you're putting your fraction. Make sure the denominator is the x minus 7. And the last common mistake, again, once we learn about the remainder, a lot of people think that this is the constant. This is the x squared and x to the third. So a lot of people have their answer as x to the third minus 6x squared minus 2x plus 4. That 4, since it's over on this side, is the remainder. So make sure you don't make that mistake. Any questions on those before we move on? All right. So the next thing we're going to do, and this is where this can snowball, and you'll use this a lot more in pre-calculus when you guys all sign up and take that class in a couple of years, which is also why, but again, my opinion doesn't matter super well, so that's okay. Fairfield's always been the school. They've never changed. When I was in high school, they always did geometry first, then algebra 2. No one else did that way. And out of all the schools I've been at, they've changed 3 or 4 times in like the 5 years I was there. But you got to compliment Fairfield on their consistency. Okay. So here's the thing. So far, we've been dividing, and that's super nice. We take a polynomial, we divide it by a binomial, we end up getting another polynomial. Everyone's happy. No one's happy, but everyone's happy. So now we're going to find what all the other zeros are. Now, again, there's methods where you're going to get a lot more of a deep dive into this. But for our purposes, we'll just start out where, I mean, there's 2 options. I could give you a factor or I could give you a 0. We've done both of these problems already, at least the first half of it. Again, both of these, if I give you a factor or a 0, that means we're going to get a remainder of 0. Since I'm not using the division sign like I did earlier, you're definitely going to get a remainder of 0 for these. And again, you don't actually need to know that like on the test to get 100%, but I think it is very handy to make sure you can check your work away. We're going to do this the same way. So we're not I must have just been in the zone, but that's no different than not an X. So if I confuse you, like every other synthetic division problem, we get x is equal to 3. So that number goes in my box. I have a 1, a negative 13, negative 15. Drop your 1 straight down. 3 times 1 is 3. Add those together. 3 times 6 is 18. 3 times 5 is positive 15. Add those together, you better get 0. That's what I was talking about earlier. So then we are left with, again, if you want to label your remainder 0 or constant, our x and our x squared. So we're left with x squared plus 6x plus 5. That's everything we did Monday. That's what we did Monday. I gave you a factor. We did synthetic division. Now, the only difference, and you can tell because, again, they're going to ask you, what are all the other zeros, or list all the zeros. or given 1 0, list all the zeros. We're going to make a list of all the zeros. And the good news is, again, I'm not going to make this difficult. They're all going to be like this one, where once you are finally done, that's not our answer yet. We need to find the zeros for those. Now, the good news is you already know how to do this back from chapter like 4, where that's a quadratic. We're going to find the zero for that. So you could use the synthetic, or you could use the quadratic formula. I personally wouldn't. You could use graphing. Again, I probably wouldn't. I would use factoring. Now, I'm not going to try, this is not a factoring chapter. I'm not going to give you anything crazy hard to factor. I'm not going to give you any with leading coefficients. I should, but I'm not going to. I'm not going to give you any like factor by grouping problems or anything crazy. That's all in the factoring chapter. This is not over factoring. I just need you to know done here. Now we can use this to factor. Over here, x, I have 1 times 5 goes to the top, my 6 goes to the bottom. I need 2 numbers that multiply to be the top and add up to be the bottom. The only 2 numbers that multiply to be 5 are 1 and 5. Luckily, they add up to be 6 with x plus 1, x plus 5. And say, so what makes each one of those 0? So we get -1 for this one, -5 for this one. Now, I have not printed out the test, but I think I'll probably do this. I think it's the easiest way to do these on a test or a worksheet or whatever is before you start or sometime in here, put a spot where you put zeros. That's another thing to call them. And that's where I'm just going to make my list of all those. My zeros are -1 and -5. However, don't forget the other. Forget your original 0 that we started with. We said from the very beginning, x is equal to 3. That's a 0. And honestly, in my opinion, that's the hardest part. Because again, I don't think this math is super crazy. It just takes forever, and then there's little things to forget. And so that's one of the reasons that when I start these problems, a lot of times, and I didn't do it on this one because I wanted to show you how it starts the exact same. But a lot of these, the first thing I do is I put the 3 down, so I don't forget that. Last thing I'll give you, the last little bit of help that I'm going to give you, that again, if you don't remember this, but one thing you'll learn, and again, you'll go a lot more into a deep dive on this in pre-calculus. We might get into it a little bit in this class. But your degree, this is not a good definition, but our degree, for the most part, is our highest exponent. That's not a good definition, but for our purposes, that will work. Whatever that degree is how many zeros you will get. So if you get -1 and -5, that's good, but you need one more because you need 3 zeros. Now, again, for our purposes in this class, not to be that guy, not to like make it super easy on you or easier. It's not obviously super easy. But for our purposes, they're all going to have 3 zeros. Mainly because that way you can take out a 0 with synthetic division, and then you have a nice quadratic that we factored a bunch of times before. So that gives you 2 more zeros. So for our purposes, they're all going to have 3 answers. I should make that different, but I'm not going to. Now the other one, again, it might not be a bad idea to list your zeros here. Okay. And the good news with this one, because people, it's just something really easy to forget. But one of the zeros is -5. They tell you what that is. And a lot of people don't write that down as their answer, and they say, well, but they already gave it to you. Well, I mean, kind of, but I want to make sure you know what that is. And ultimately, I want to make sure you remember there's 3 zeros because it's a degree of 3. So I write that down right away so I don't forget. You obviously don't have to. You can wait till the end. But you end up doing your synthetic division. We have -5 in the box. I have 5, 21, -21, -5. Incidental. Drop your 5 straight down. -5 times 5 is -25. And with -4. Times -4 is +20. Add those together, you get -1. 5 times -1 is +5. Add those together, you get 0. Again, we need 0 as a remainder because I told you it was a 0. So that's what gets you that 0 remainder. You know that should happen. For this one, and I don't think I did it on the test. I'll go back and probably take it off if I did. But this one does have a leading coefficient. Again, I don't think on the test, I don't think it has one. I think it's just good to get a little bit of review on factoring. That's one of the biggest complaints for pre-calculus is that students forget how to factor. So this ends up being 5x squared minus 4x minus 1. Five factors of -5 that add up to be -4. The only factors of 5 are 1 and 5. So which one gets the negative? It's got to be the -5 since you end up 1 plus -5 is -4. You get x plus 1, x minus 5. So this is the part we have to be careful with. Since there's a leading coefficient, we divide both of these by that leading coefficient. You have your fraction reduced, you can put that denominator in front. If the fraction is not reduced, and lastly, again, this problem is hard because it takes that. So if you solve 5x plus 1 is equal to 0, in my opinion, if you have a number in front, I would not do it in my head. I would actually list it out. 5x is equal to -5 by 5. So one of your zeros is -1. These here is +1. So +1 and -1/5 are your other zeros. This is where I hesitate because I know some teachers would say I should give you ones with leading coefficients because I should make sure you're good at that. But also for me, it's hard because I already graded you on that standard. My standard I'm looking at now is the synthetic division part. So that's what take I'm going to do on it. So you, on the test or quiz or the test, you won't have one with leading coefficient. Let's go ahead or the UDO. I'm going to do number 7 for you guys because we only have about 10 minutes left. If you want to work on your worksheet instead and start that, that's fine. The answer key's up there. But I'll give you the answer to number 7 here in a second if you want to look at that one. And then there is an exit ticket to this. Remember, tomorrow we'll go over your quiz and we will go over question and answers from the practice test. I apologize I didn't get that to you guys earlier.